Well, hello and welcome back to math class. As you can see on the screen, the first thing I would like for you to write down in your math notebook is the lesson we are going to look at today. We are starting lesson 7.1, which is chapter 7, and we're going to talk about areas of parallelograms. Now, if you want to ever go back into your book to see what pages this are in case you want to study it, we're going to actually be starting on page 285 of our math book. So if you would write that down, please. All right, well, so we're going to write a definition in our notes, and the definition we're going to write today is the word polygon. What is a polygon? Well, I want you to know that a polygon is a closed, so we're going to write the word closed, figure that is made up of 3 or more line segments. Okay, line segments. So for example, a three-sided polygon could be a triangle. Could be a rectangle. Could be a pentagon. Okay, has to have 3 or more line segments. A circle would not work because a circle would not have line segments. All right, go ahead and finish writing that down. Okay, so today, as you can see, we're going to learn the formula of the area of a parallelogram. Well, the area of a parallelogram is the same as the area of a rectangle. So, for example, if we make a picture here of another rectangle, how do we find the area? Area equals, and in our textbook, it makes a cursive L like this, length times width. Now, for some of us, we like to remember that this means multiply, so we'll put a little times in there. This side is my length side, and this side is my width side. This is considered a parallelogram. Why? Because a parallelogram has this side is parallel to this side, and this side is parallel to this side. So it has one set, two sets. Sometimes a parallelogram can be drawn like this. We'll see if we can practice. So we'll make a line here. And the parallel line, we want to kind of bring it over here a little bit. And we'll stop, and then we will close it up. This is considered a parallelogram. Well, what is the formula of a parallelogram? The same as a rectangle. The length times the width. Here's my length. My width. Well, a lot of times people want to do this. If you noticed or listened in math class, Mrs. Hauck started changing it to area equals base times height. And the reason I've changed it to base times height is because the base is our bottom, so we'll change this to a B, and the height is from the bottom line to the top line. However, the rule is the height has to be straight up and down. If you notice, this is not straight up and down. And because it's not straight up and down, we have to make our own little line that goes up here like this, straight up and down. It makes a 90-degree angle. That is called our height. This is not our height. The length of this diagonal line and the length of the measurement from the top line to the bottom line would not be the same distance. All right, so here is a parallelogram that I've drawn on graph paper. This way we can see it a little bit easier. If you notice, this down here is my base. Okay, so if you remember, we're changing the formula. We're not going to say length times width anymore. We're going to say base times height. Okay, so here's my base, and if you're listening, the height cannot be a diagonal like this, because if you notice, from the top line to the bottom line, there are 1, 2, 3 boxes. But if you would try and measure here, it looks like 1, 2, oh, and it's hard to count right here. And so that's why we don't use the diagonal as our height. So I would have to make a line from the top to the bottom. It makes a perfectly right angle. This is considered my height. All right, so if you notice now, I've cut my parallelogram out so that we can see it a little bit easier. Here's the base and here's the height. If I had to find the area of this parallelogram, I would say area equals the base times the height. Let's look at the base. If I count these boxes, this corner box would be considered 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's gone from here to here was 9 boxes. Oop, I'm moving this here. So I would say my base is 9. Let's count the height. How many boxes? 1, 2, 3. And so the height is 3. So my answer would be the area equals 27. Now I didn't tell you if it's inches or centimeters, so we would just label it units squared. All right, so now I'm going to show you something else. You notice here I have the same parallelogram as I do up here. Okay, it's exactly 9 by 3, so this is still 27 units. Now what I'd like to show you is this shape is a parallelogram. If I would break this off over here and slide it off, you notice now the parallelogram has turned into a rectangle. So let's see if I can get that a little bit better for you. All right, so I basically took the parallelogram, I cut off this side over here, and I moved it over here. I didn't cut anything off. I didn't take anything away. These two shapes have exactly the same area. Their shape is not the same, but the area is exactly the same. This was base times height, which is 9 times 3. If I look at my rectangle, we a lot of times think of this as length times width. Well, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes across. 1, 2, 3, and 3 up would still give me the same answer. So that's why a lot of times we compare, whoops, let me fix this mess. Okay, there we go. So that's why we compare parallelograms and rectangles. They are exactly the same area, or can be, depending upon the length or the base of the two shapes. Okay? The number one thing I want you to remember about parallelograms is when we are multiplying, it's base times height. Be careful. I'm going to try and trick you today. The height is the one that goes straight up and down, making a perpendicular angle or a right angle, not the diagonal. All right, so let's go back to our notebook this time. I'd like for you to draw. Let's make here a straight line like this. And let's count down about 1, 2, 3 lines. And remember, we're going to make a parallelogram, so we're going to kind of go over to the side like so. Bring down diagonals. And we've made a parallelogram. If I told you that the base down here is 12 meters, and I told you that the diagonal right here is 16 meters, do you have enough information to find the area? No, you don't, because the area of a parallelogram is base right here times height. This is not a height, this is a diagonal. So that means I would need to share with you a measurement that goes from the top straight down, makes a right angle, and if I told you that that was 14 meters, now solve the area of my parallelogram. So you would write the formula area equals base times height. You would substitute in for base using the number 12. You would substitute in for h using the number 14. And you would multiply those two numbers. I have here the answer 168. And so my area would be 168. I have a label, so we'll say meters squared. All right, let's try one more practice problem. All right, this time let's take and make our parallelogram go the other direction. So we'll take a line, make it here. Let's make our other line maybe over here. And this time we're going to draw our diagonals. I'm going to tell you that the top up here is 4 feet. I'm going to tell you that the diagonal right here is 10 feet. Once again, I have not given you enough information. The information I've given to you is, 4 feet. Well, these two would both be 4 feet. And these two would be the same, but I don't want a diagonal. I need the height. So somehow I need to have a line that goes from the top to the bottom. Sometimes your book will show you this. It'll take and make a line like this and over here like this, meaning this is my height, which is the same length from here to here. It'll put a little right angle there, and it'll say your measurement. Let's say we have 8.5 feet. So from this point straight down to where my parallelogram could extend, this is 8.5. So my formula is area equals base times height. I'm going to substitute in for my base. My base is 4. And my height, not the diagonal, my height is 8 1/2. Okay, let's see if we can remember how to multiply fractions. I'll put 4 over 1. 8 times 2 is 16. Plus 1 is 17 over 2. I'm not flipping because I'm not dividing. See if you can solve my problem. Some of you might have simplified right here because you notice you can simplify two numbers. Some of you might have multiplied across the top and multiplied across the bottom. Either way, you still should come up with the same answer. If you multiplied across the top, you probably have 68. And if you multiply across the bottom, you have 2. 68 divided by 2, my answer would be 34. My label, can't forget my label, would be feet squared. All right, we've done a few practice problems. You may go ahead and put your notes away.